B2 starts out with question number 16. Which compounds are isomers? And remember, isomers have the same molecular formula but different structural formulas. So what you're going to need to do is you're going to need to draw the formulas for all of these things. And when you do that, you will see and be able to determine which one is different. '17 says the correct structural formula for 2,2-dimethylpropane. So propane means they have to have three carbons, okay? And then 2,2-dimethyl means you're going to have two methyl groups on the same carbon. So we can look at this. So number one, we have 1, 2, 3, 4 carbons. That ain't it, because we're looking for 3 carbons. Number 2 has 1, 2, 3, 4 carbons in a row, 5 carbons in a row. That ain't it. Number 3 has 1, 2, 3, 4 carbons in a row. That ain't it. This one has 1, 2, 3, or we could say 1, 2, 3 the other direction. But anyway, it's going to have 3 carbons, and there's your propane, and 2,2-dimethyl. Well, here's one methyl group, and there's the other methyl group, so there's your answer, 2,2-dimethylpropane. 18, the process created there, the only thing that's missing is yeast as a catalyst, and when you see that, you're like, oh, wait a minute, I'm producing an OH, and I'm producing CO2. So therefore, that is the process of the reaction used to produce polyethylene from ethylene. All right, if we're going to do polyethylene, and remember we have a unsaturated are going to be addition reactions because they are both starting with a vowel. So they're both going to be polymerization. One is the correct answer is the addition one. The structural formula represented by the products of this. So C2H4 is going to be that compound, and then you're going to add a chlorine to it. And again, this is an addition because this thing here is unsaturated. That should be unsaturated. I don't know what I was trying to spell there. All right, but unsaturated. And if we're adding something to it, you're going to break that bond, and it's going to have those on there. Methanol. Methanol is 1 carbon, all right, and it's an alcohol, which is going to have the OH functional group, all right, and so that has to do with these definitions. Monohydroxy means literally means 1 OH. A secondary alcohol, that definition means that the OH is attached to a carbon, is attached to 2 other carbons. Well, we only have 1 carbon. Tertiary alcohol says the OH is attached to a carbon that's attached to 3 other carbons. Again, we only have one carbon. And then dihydroxy means that has 2 OHs, while methanol clearly only has 1 OH. Total number of pairs of electrons that one carbon atom shares within the C2H4. So C2H4 means you have an alkene. All right, remember your hydrogens are out here, C2H4. And when we're talking about this, the total number of pairs of electrons that one carbon shares with the other carbon, remember, each one of these lines represents a pair of electrons. Each one represents a bond. So we have a total of 2 pairs being shared between those 2 carbons, or 4 electrons. 23 is asking you which one represents a hydrocarbon. hydrocarbon means it has hydrogen and carbon, and that's it. 24 is asking you, do you know the properties of an organic compound? Organic compounds have low melting points. Organic compounds are generally insoluble in water. Organic compounds generally decompose under high heat. Organic compounds are typically not an electrolyte. So you go through there and figure out which is the best answer of the bunch. '25 says, which hydrocarbon is a member of the alkene series? So for this, you're looking, okay, which one has the ratio of the alkene? The alkene ratio is the number of hydrogens is twice the number of carbons. And so all you're doing is looking and seeing which one has so this one's missing the H, I don't know why that is. But anyway, you're looking through here. All right, so that hydrogen here, for this one, the hydrogens is just the same as the number of carbons, and it's not twice, so that's not it. This one, B, the number of hydrogens is twice the number of carbons plus 2. No, it's twice the number of carbons. 3 times 2 is 6, so I like that one so far. In number 3, I should get rid of those arrows. Those arrows are misleading. Hang on. In number 3, twice the number of 4 is 2 times 4 is 8 plus 2 is 10. So we want 2 times 4, so that's not it. And number 5 is 12, so the number of hydrogens is twice the number of carbons plus 2 again. So your best answer is number 2. 26 says, given this equation representing this, what's going on? Well, remember, we have a double bond right here. There's your double bond. All right, that means it's unsaturated. And what type of reaction goes with unsaturated when you're putting something onto it? All right, we are this kind of, that tells you right there, because you only have one product. 27 says, which organic compound will dissolve in water to produce a turned litmus red? This one, again, you guys did not know because we haven't done acids and bases. That phrase right there, turn blue litmus red, any substance that turns blue litmus red is an acid. So, therefore, we have to find something that is an acid, and it's got to be an organic acid, so that we have to consider table R. And when we consider table R, we're going to look for the organic acids. An organic acid is this thing here, so you're looking this functional group of the COOH, and you're looking for that. Ethanediol. So first, start with the root of eth. So you're going to have 2 carbons. All right. Then we're going to have the suffix of diol. So that means this, even though it's got 2 carbons, all right, we're going to have a 2. Di means 2. All means OHs. So we're going to have 2 OHs. And where are they going to be? They're going to be on the first and second carbon. So we're going to have an OH on the first carbon. We're going to have an OH on the second carbon. And so this is an OH, or excuse me, this is a compound that has 2 OHs. And when we look at our different choices, monohydroxy means 1 OH. Dihydroxy means 2 OHs, and there's our answer. Primary and secondary alcohols have to do with the OH, the carbon to which the OH is attached, and when we're looking at these, it gets a little tricky. So we're going to go with the simplest answer, which is dihydroxy alcohol. Ketone means you have to take a look again at table R, and so you're looking for an O, a single bonded O in the middle of the compound. The first one has a COOH. That is not it. This one has an OH. That has a single O in the middle. This has 2 O's in the middle. We're looking for 1 O in the middle. There, it narrows it down. Those 2 compounds, they have the different functional groups, therefore they must have different properties. If they're different functional groups, they are different properties. The question's really getting to the point over the fact is they both have 2 carbons, they both have 6 hydrogens, and they both have an oxygen. These two things are isomers. Isomers, all right, means they have the same molecular formula but different structural formula. The fact that they have two different structural formulas and more specifically two different functional groups because they are functional group isomers, this means they're going to have different chemical properties. The mass will be percent composition by mass will be the same, number of atoms per molecule, gram formula masses. That's all going to be the same. The properties are going to be different. And that gets us to the end of B1.